So, welcome to part 4, chapter 2. Today, we're going to talk about something called as our pH scale. So, when we say pH scale, remember it this much. You always write small p and capital H. Okay, small p, capital H. And the pH scale starts from our 0 and it goes up to 14. 7 will be exactly in the between. So this is our pH scale. Our pH scale, or it's a level. Suppose I told you here we have got, suppose our HCl. The pH level of HCl is 0. Suppose we have got NaOH. The pH level of NaOH is something 14 point something, 13 point something, or 14, near 14. So here suppose water, we have got water, the pH level will be 7. So depending on what the level of the pH is, we can know whether something is acidic or basic in nature. The levels from 0 to 7 are acidic, and more than 7 are basic, and 7 will be neutral. I hope you remember neutral. Already I told you the neutral meaning. What is neutral? Neutral was, it was not exactly 0, it was neither this side nor that side. That means neither positive nor negative, neither good nor bad, or in this case neither acid nor base. So in between. So here our water is neutral, that means water is not acidic also, water is not basic also. So here this is how we determine how strong an acid is. The If you go from 0 up to 7, if you go this side downwards, the more downward you go, the more stronger the acid will be. You go this side up to 14, the more you go towards 14, the bigger the number is, the more basic it is. I hope you got it. So in short, we can say of the pH scale, our 0 is the strongest acid. If you go downward, it becomes weaker acid, weaker acid, weaker acid. At 7, it will neither be acid nor base, it will be exactly neutral. And as you go furthermore up to 14, the 14 will be the strongest base. Okay, so here one point I forgot to mention. When we were talking about base, let us say our NaOH, KOH, CaOH2, MgOH2, maybe our AlOH3, all these bases. Okay, one point was there, that is all of the bases cannot dissolve in water. When we talk acid, HCl, H2SO4, no matter what acid you take, they will dissolve in water. Okay, but all bases cannot dissolve in water. Only certain base can dissolve in water, and those bases which can dissolve in water are what we call as alkali. And so here only certain bases will dissolve in water. And which bases will you remember it, or how to remember those bases which can dissolve in water? You have to know the PSC muscle. Okay, I hope you know it already, or you remembered already. We had our PSC MAZ. Keep it on the other side. So it was potassium, sodium, calcium, and magnesium. Out of the most common bases which we are going to use, this top four metal. Remember, this top four metal, when you put an OH, they become a base. OH, OH2, because valency, calcium valence is 2. It has similarly Mg valency 2, so MgOH2. And the remaining, let us say Zn, OH, 2, and all. Other than these top four metals, the others will not form alkali. Only these top four metals are the bases which we commonly use will form alkali, and the remaining they are not going to form alkali. What is alkali? Base which can dissolve in water. So I hope you got it. The point is clear. So here anyways we'll be talking about our pH level. So there's a small picture there you can see on top. Here the pH scale is given. So it's a scale, you can see the same scale in the book also in your page number 26. So just like we have got litmus paper, a special paper is there, okay, which we call as a pH paper. So let us say I took a pH paper and put it in a acidic medium, okay, and the pH paper became red. Because it's an acid, it will become red. Now what will I do is I'll compare this color with this scale. Which color is it matching most? It seems like it's matching with the number 3. So I will say, okay, the pH of whatever liquid I had was 3. Same way, suppose I put there a basic solution. I put a pH paper and my pH paper became, let us say, this much blue. Then I will check with which blue is it matching. It is matching somewhat with this third number, number 12. So okay, I will say the pH is 12. So this is how we identify the pH. We need a natural indicator. Here we are going to use a pH paper, and this pH paper will change color according to acid or base, and will compare how much color is changing or what is the amount of color changing, and we'll compare it. And if it gives that whatever color is matching from this here, we'll call it again pH is this level. So I hope this part is clear. So this is all about our pH. So let me clear this canvas. Here, so we understood that pH of acid, let us take our HCl will be, okay, 0, let us say, and our, let us say, pH of NaOH, which is a base which dissolves in water, so I will call it what, alkali, will be 14 maximum. Okay, that is strongest base, strongest acid. So let us compare something. Here we know when I dissolve this HCl in water, it will give us lots of H plus and lots of Cl minus. Let us say this below gave us 100 H plus and 100 Cl minus. And we already learned here actually it's not H plus, this will react with water to form H3O plus. Okay, so when I say H plus, you understand it is what I'm meaning is hydronium ion H3O plus. Here our base, let us say Na gave us Na plus. Let's say here so there's 100 NaOH, so it will give 100 OH minus. What we can see is strong acid will break up completely to give full H plus and full Cl minus. Strong base will give us full Na plus and full OH minus. So what we say is, as we go from 0 towards 14, the amount of H plus will become less. There's a graph. Okay, 0 will have the highest number of H plus and 14 will have the lowest number of H plus. However, for OH minus, here base will have the highest number, but here our H, what is it, acidic will have the lowest number of OH minus, the base will have the highest number of OH minus. So that means a base will have more H plus, a acid will have more H plus, a base will have more OH minus. A acid may have little bit OH minus, a base may have little bit H plus. Here in the 7, that is neutral, the amount of H plus is exactly equal to OH minus, so they cancel each other out. Okay, as a result what we get here is it's neither acidic, that means nor H plus is more, nor basic, nor OH minus is more. So I hope this part is clear to all of you. So one final thing to understand about our pH scale. Okay, so what exactly is a pH scale? It tells us how strong something is, acidic or basic. In simple words, it tells us how much H plus ions something have, or AQ that is needed, I told you, or how much OH minus ions is present. Actually it measures in terms of H plus aqueous ions. Okay, so let me take concentrated HCl And let us say here concentrated HCl have got pH of 0. Dilute HCl. What was the difference between concentrated and dilute? Concentrated was, let us say, out of 100 HCl present in 100 water. Okay, dilute meaning what? Obviously less number present in the same amount of water. In 100 water, let us say only 10 HCl is present. So this is weak because less acid is present. Here more acid is present. Okay, more acid meaning what? Obviously it will release more number of H plus. Less acid meaning it may be able to release only, suppose if here 100 HCl can release 100 H plus, here our 10 HCl can release only 10 H plus. So obviously this will be weaker acid. Now what we see is, because it is releasing less amount of H plus, that pH value will be bigger than 0. Let's say maybe 4. So what I'm trying to tell you here is, even though it's HCl, both of them are HCl, concentrated HCl has got lower value of pH, means more stronger acid. Dilute HCl has got higher value of pH, means it is not as strong acidic, or it is a weaker acid. Reason is, concentrated HCl contains more HCl, so it can release more H plus. Dilute HCl has got less HCl, so it can release less H plus in water. More H plus means more, what is it? More acidic. Less H plus means less acidic. I hope this part is clear. So what we get here is, the same compound may have different level of pH depending on what is the concentration. Is it concentrated, dilute, is it strong, is it weak? So depending on that, what we will find is different, same chemical or same compound or same acid, there's a chance of it having a different value of pH level. So I hope this part is clear. So let's go next to the salts. So already I told you, how can you get a salt? You react either acid or base with something, or you react acid and base, and we will get salt. Here salt plus acid and base, we got salt plus, what was it? Water. Okay, acid and base when they react, we get salt and water. So here we already know this reaction is called neutralization reaction. Why neutralization? Because acid and base cancel each other out. So our salt that was formed is generally neutral. So pH will be definitely 7. Neutral means what? pH 7. However, there's a problem here. There's a catch. Thing is, if we're using acid which is very strong and strong base, then our salt will be neutral plus water. However, if you're reacting strong acid with some weak base, maybe weak base meaning, let us say we're getting some NaOH which have got less concentration or so on, what happens is our salt will be acidic in nature plus water. Why acidic in nature? Because the acid is stronger and base is weaker. So this weak base, it could not cancel out all the acidic characteristics. So some acidic characteristic will remain in the salt. Similar case will happen if we take weak acid with a strong base. Then our salt will be obviously what? Basic in nature. So I hope this part you got it. So here it was just a basic idea about salt, and we're going to talk about one kind of salt in particular called as our NaCl. What is NaCl? Sodium chloride, or this is called as common salt. Why common salt? Because this is the salt which we use in our common daily day-to-day purposes. So where can you get NaCl from? We get it from our sea or our ocean. Okay, so here what we can do is, how can you extract salt out of ocean? What we do is, suppose this is the ocean boundary and this is the land here. So let me put the ocean in blue color. This is the water. So you know already what happens during high tide and low tide. The water comes up or the waves come up. Then what happens here? They make small patches or they block it with sand. So when the water comes and fill up here, water will stop in this region, and then later on the water is allowed to evaporate, and the salt or crystal salt is found here, and that salt is taken out and then purified using the process of crystallization. Crystallization technique, I hope you remember it. It was found in our class 9. Okay, if you have doubt about it, then you can ask me in the class. I will explain it afterwards later on. So this is our NaCl is found. Sometimes NaCl can be found in places where it's not an ocean. Let's say this is the earth and this part was ocean. Let us say earlier, very early days, means prehistoric, before human beings started, before the dinosaurs, or maybe dinosaur time. This part was, let us say, ocean. But gradually what happened? We already know ocean contains salt. So gradually this ocean dried up and the rain started to fall in this region. So right now maybe the ocean is here, or maybe clouds and all gone. So let us say this region got dried up, and what happened? Some land came and mud came and it got covered. So here this area now has got lots of NaCl inside, but no water, is dry right now. So this can be mined, just like we mine for coal. This can be mined and we call it as the rock salt. The salt which we find in the earth's crust, which we can mine it, we call it what? Rock salt. So here the important thing is, why are we so much focused about salt? Because salt is a very important compound which we can use it as a raw material. Raw material meaning what? We can use it to make some other materials. From our NaCl as a raw material, we can give an alkali. What alkali? Our NaOH. What is alkali? Base which can dissolve in water. NaOH forms Na. So I already told you, PaCm. These top four can dissolve in water when they form OH and sodium. Yeah. So alkali. We can get chlorine gas and we can get hydrogen gas also. I already told you, two meaning what? Gas and gas. This whole process of how we're getting it is what we call as the, or we're going to study it under chlor-alkali process. Why chlor? Because we're getting chlorine here. Why alkali? Because we're getting alkali here. So process. So here what we can do is, we can take a beaker. Let's say we put water here, and we put electricity, electrodes. Maybe this is the plus and this is the minus. Plus is called the anode, minus is called the cathode. And what we do, we put the salt inside here, NaCl. Let us say this red color is the Cl. Okay, red is the Cl, and let me write green color as the Na. Okay, so here what we see is, when we pass current through water, if the salt is not present, will the current pass through the water? No, because pure water does not conduct electricity. However, if you mix NaCl in the water, it breaks up into Cl minus and Na plus. Now this plus and minus will help the current to pass from this plus to minus, or the electrons from this minus to this plus. Okay, so what you get is, when we pass electricity through such a setup, the water molecule present inside will also break up into H plus and OH minus. Okay, so in this case what happens, this minus will try to pull this H plus. Again, who is plus here? Our green color or the Na is plus. However, Na is bigger, H plus is smaller. So H will go this side. Okay, here OH is minus and Cl is minus. In this case, this plus will pull this OH minus towards it and this Cl minus towards it. In this case, our OH is bigger, Cl is smaller. So Cl will be the one who will go there faster. Okay, so what we'll find is lots of Cl will collect here, Cl, and this side lots of H will collect here, H, and when two Cl join together, they form Cl2, or they take the form of a gas. When two H join together, they form H2, or they take the form of a gas. So as a result, in our cathode, we are getting hydrogen gas. In our anode, we are getting chlorine gas. And what is left out here, who could not move? OH was the one who could not move, and Na was the one which could not move. So they'll join to form our NaOH. So this is how, from this reaction, we are getting chlorine and alkali, which is NaOH, and hydrogen gas. And this process is what we call as chlor-alkali process, and or we call it electrolysis of, wait, what was the name? I forgot. Brine. Electrolysis of brine. What is brine? A mixture of water and NaCl, or a solution of sodium chloride plus water is what we call as brine. Electrolysis means passing electricity. So electrolysis of brine is what we call as chlor-alkali process. Now you can do one thing, you can take a test tube over here and collect the gases formed, and you can use it for some other purpose. For example, chlorine, we can use it in making bleaching powder, which we are going to see in the next part. So okay, from the previous reaction, that means our chlor-alkali process, we managed to get chlorine gas, yes, Cl2. Now using this Cl2, we can make our bleaching powder. The formula for bleaching powder is CaOCl2. Okay, here we already know what is bleaching powder. You have seen it maybe. Bleaching powder, what do you do in your well or where you wash your clothes and all? That green color algae gets collected when, because it's very wet, that times it become very slippery. Or to clean something very dirty places, what do you generally do? We throw bleaching powder there for some time, and it will, what is it, it will react with that substance, the dirt, and we clean it. Yes, so here it's given in our page number 31, the first part, uses of bleaching powder. It is given that it is used to in bleaching cotton and linen in the textile industry, meaning suppose whatever cotton or whatever clothes we are making out of cotton, you have seen the cotton, that cotton plant, is it white, perfectly white? No, it's little yellowish white. So to make it very clean, or to remove all the color and make it white, we can use it in our textile or cloth industry. Here it again is given for bleaching wood pulp in paper industry, like the paper is made from bamboo or some tree pulps. Those are not perfectly white. Some dirt will be there, but some color will be there. To remove the colors, we can use bleaching powder. Second part is given as an oxidizing agent in many chemical industries. Oxidizing agent means, do you remember it? What was it? It was some what was oxidation? It was what? Adding of oxygen or removing of hydrogen. So let us say we had C plus, wait, that's right, Ca plus, let's take H, not H, let's say zinc, Zn2O, sorry, Zno, we will get CaO plus Zn. We notice that here Ca did not have oxygen, now the Ca have oxygen. So we say calcium got oxidized to form calcium oxide. Zinc oxide got reduced to form zinc. Here, who was the one who gave the oxygen? Zinc oxide had oxygen, it gave the oxygen. So here zinc oxide is what we call as the oxidizing agent. Or in oxidizing agent, what we see is the compound which loses oxygen and gives the oxygen to someone else is what we call as oxidizing agent. Here we can see in bleaching powder oxygen is present. So can it lose the oxygen? Yes. Can it give the oxygen? Yes. So it can be used as oxidizing agent in certain chemical industries. And here last it's given for disinfecting drinking water. That means when I put bleaching powder in a certain water, the germs generally die. Because of this chlorine present in there, the germs will generally die. As a result, we can use it to disinfect water and make it clean for us to drink. This, what is it? Disinfecting using chlorine or bleaching powder is mostly common in our purite. The filter which you buy, that purite, there it is generally used, this technique. So here when we talk about the reactions of bleaching powder, it's very complicated, okay, but it's given here. Bleaching powder is, how do you get it? We get it by passing chlorine or reacting chlorine gas with dry calcium hydroxide or slag lime. So when you take CaOH 2, which is slag lime, and you react chlorine to it, then we generally get bleaching powder, CaOCl2 plus H2O. Okay, now don't think this is a complete new reaction. Don't think that it will become very hard to remember. You know this reaction already. CaOH2 normal slag lime. If you react carbon dioxide, what do you get? We get CaCO3 plus H2O. Was it? This is the lime which after putting in water we got it. We put it in the walls. In the wall carbon dioxide is present in the air. It will react to give us shiny calcium carbonate plus water will evaporate. So compare the reaction. See, same, and water is same. Just here, instead of carbon dioxide, we are passing chlorine gas. So instead of calcium carbonate, we are getting bleaching powder. So you remember that. It will be very easy. Okay. So here in chapter 2 or whatever in the chemistry part, when you look at the reactions, you need to know certain basic reactions. Afterwards, you can compare the other reactions with those, and then it becomes very easy. There are only one or two some more new reactions to learn from here. If you can see in the book page number 31, lots of reaction, page number 32, 33. Out of those reactions, only two you need to remember, others all is already we learned it. Okay, so then in the next part we will go for the baking soda and learn how to make the reactions.